All right. So I was going to talk just briefly about the CNC plasma cutter and how it kind of works. And it's really easy to use, aside from metal being expensive. And so there's some appeal to showing you guys how to use it so that you can get inspired to possibly make some stuff. So let me share my screen here real quick. And that should work. All right, can everybody see my desktop here?
Yep.
So I make some labels for the plants out in front in the terrace. I figured people are less likely to complain about them if they know that they're plants that are supposed to be growing in the terrace and that we want them to be there, and they might be taller than grass and uglier than grass, but they're supposed to be around. So Jim was kind enough to give us a bunch of raspberry plants, a bunch of strawberry plants after they got done doing the water main construction out there. And then Solomon Seal's a native Wisconsin plant. It's kind of got like an arc to it with sort of oval leaves that alternate, and then it's got little tiny flowers that hang below it.
It's a good thing my wife can't see your bad kerning.
Oh, come on now! There's a whole bunch of stencil fonts, and this is just one of them. There's always somebody into fonts. At least Kate's not here to yell at me. She'd be after me too. So anyway, what I'm gonna do then to make a drawing is essentially we'll look in. I'm using CorelDRAW. You can use Adobe Illustrator or whatever else floats your boat. Inkscape. So I've previously downloaded some of these stencil fonts. There's a whole ton of fonts out there if you search for stencil. They are essentially, or you can make your own. But the key thing is that if you have floating letter centers, they need to be. It's actually a bad. Let's see here. There we go. So if you have floating letter centers, you need to support them so that they don't fall out of your shape. So you can see on here, all of these have bridges going to what would be the frame. So if we're going to cut this out, we'd have a frame around it. And this would keep the O floating in the middle and the D center floating in the middle and the G center floating in the middle. And you generally want these to be wide enough to hold the piece, but not so wide that it obscures what the letters are supposed to be. And then they're typically, for most stencils, all consistent. So you can see the width on these is all identical. Some of them vary, like this one's kind of creative. The M is unnecessarily supported, the L as well, just whoever made the font's choice. So long story short, we would pick our font out or make our drawing or design. So I, of course, have already saved DXF file as a vector of just this raspberry text. And so in this case, we just export it as a DXF in inches. So like I said, I already did that. The plasma cutter has conversational mode built in. That means that you can just go to it with the DXF file and it'll cut from a DXF file. So this next step is unnecessary for simple designs, but for complicated designs, there's some software called SheetCam. If you've ever used any other CNC software like Fusion 360, where you can generate machine code from it, or 3D printer files where it's generating the layer, like the perimeters and layers and fills and whatnot, this is doing the exact same thing, only in this case, it needs to generate toolpaths for our tool. So what I did here then is, if I delete this guy, I'm gonna import in a drawing. So I'll grab our text here. It's gonna ask me where I want the origin to be, whether it's in metric or inches or custom scale. You can adjust the location of it. This software also supports drilling. So getting into some more complexities with plasma cutting, it's not good at making really small holes. So some plasma cutters have a drill attached to them, so it can alternate between drilling holes and cutting out perimeters. Ours doesn't have that, but that's something that is fairly common on some of the more sophisticated machines. So in here, then you can see the software has identified all the internal shapes, and that's all the yellow lines. And then the red is the perimeter as the outside line. And sometimes it's helpful because occasionally I'll have stacked lines and layers and things. And sometimes the software gets confused about what's an inside versus an outside shape. So in here, I've pre-set up some tools. So the plasma cutter comes with a book, and the book is online. We have a Hypertherm 65 amp plasma cutter. The plasma cutter is kind of the heart of your CNC machine because it's what's making the electrical arc and cutting out your parts for you. So on here, there are a whole bunch of pieces. These are consumable pieces that you stack up to change out the tool effectively. And different tools in the plasma cutter have different cut widths. So in this case, we're going to use the fine cut width, which supposedly has a width of 38 thousandths. In my experience, it cuts quite a bit wider than that because we're not usually at the ideal height. But you can see in here, I've got my kerf width set to 38 thousandths. The tool number doesn't really matter. That whether it's a plasma doesn't really matter. The text up here, the FC stands for fine cut. SS is stainless steel. 16 is 16 gauge. So in plasma land, we care about how thick our material is. So somewhere here, I can't see it. I have a little, this little key ring kind of looking guy. And this helps us, we can slide it over the edge of material and it'll tell us what the gauge of the material is. So I can slide like a piece of metal in here and I can figure out which one it fits in. And that tells me which gauge thickness it is. You can measure with a caliper too. But anyway, the gauge thickness of your material is like the most important step. So once we have that, we then tell the software that we want to do a new jet cutting operation. And so we want to offset to the outside. We want to grab by layer. So if you wanted to sort by behavior, you do different layers. And then the rest of this actually doesn't matter at all. So we hit OK, and it generates our cut paths. So you can see on here, the big reason that we have to use SheetCam is SheetCam is really smart about how it does these lead-ins. The plasma cutter makes a big like blast hole when it starts. So in the middle of this E, it's going to make like a huge hole. And so it tries to start the torch in the middle of nowhere and then come out to the edge and then cut out around the perimeter of it. And so this software is really good about adding in these lead-ins and putting them in smart spots versus some of the other CAD CAM programs we have don't do that. And so they would just put the lead in outside of the shape or on the edge of the shape. So it would like pierce outside and then come in and then cut out the inside, which doesn't make any sense. And if you have a small shape, it just lets the pierce go outside of the shape edge. So that's all very frustrating. So software does nice on that. The other thing that the software does well is in here under cut path, we can tell it to minimize thermal distortion. So one of the other enemies of plasma cutting is you're putting a whole bunch of heat into a really thin piece of sheet metal. And when you do that, it turns into a big Pringle and it like tacos. And as it warps up, it hits the head and then your part touches and then it knocks your head out or knocks your piece out of alignment and then you're screwed. You basically have to start over on a new piece. So this thing's smart in that it distributes our cuts about 3 inches, hopefully apart from each other. So here's our number one piece that's going to cut out is here. And then you can see the 12th cut, S12 is probably hard to see, is here. So it's putting the first cut next to the 12th cut, next to the 16th cut. So it's going to kind of hop all over the shape as it's cutting it out. And it's doing that to minimize the distortion as it's cutting. So it's smart about trying to do that. Then it'll cut out the perimeter last. So that's pretty much all the software stuff. So then we go up here and we hit post-process. And we're going to save out our NC file. The NC file is just G-code, so it's the same G-code as you're used to seeing. The only things that are a little bit different are the software on board controls the pierces and stuff and the behavior of the torch. So come on. It uses like a G15 to touch off. So every time it starts the torch, it goes down, finds the height of the material, and then goes up a certain touch off distance, and then it burns a hole or starts the torch and cuts. So it uses two different special G codes, a G15 and a G16 to accomplish those tasks. So we'll see that on there fairly often. So I guess anybody have any questions? And then I'm going to wander back to the welding shop with my phone. So questions? Oh, Davie's screaming behind me, but Jim's got him on mute, so this is convenient.
Can you hear me?
Yes, sir.
I have two questions so far, and I won't tell you what I do for a living. The conversational on the plasma, is that going to punch a bunch of holes on the outside, and that's why you chose to use SheetCam? And is SheetCam free?
SheetCam is very not free. I think it's like 100 or 300 maybe a license, something like that. It's like less than $300. That said, the onboard stuff doesn't do that distribute pierces for the thermal distortion. So it's not smart enough to. There we go. Sorry, I get my phone working. So it's not smart enough to distribute your cuts and your pierces. And then, all right, hang on a second. I'm gonna switch what's getting my video here and my audio. All right, can everybody hear me still? So we're gonna head back to the plasma cutter. And I'll show you on the plasma cutter the what it does for the conversational mode, because it basically, oh, I think Davie's running. This will be perfect. He can hold my camera for me.
He's off right now.
Yes, I know. Hang on a second. We're getting there. I figured he didn't need to see the floor all the way back here. All right, I've got my lovely assistant here. He's oh, there he is. And
Can we do landscape mode?
there we go. Here you go, boss. All right. First step.
Landscape.
So, all right, this is our control software, and this is Pathpilot from Tormach. So I'm going to plug in my thumb drive.
Now you're in still in portrait mode and just sideways.
Oh god, that's even worse. Let's just leave it portrait mode. That sounds like a better plan. Sorry. So anyway, on here we've got our files. So I'm going to copy over my DXF file so we can see what the conversation mode does. This software is a very beta version of it, so this is really what it looks like at the moment. I'm sure it's been updated. So if we load up our file on here, that was interesting. The first thing it did is it rotated it sideways. Oh, there we go. Hey, look at that. We got her. My assistant's on. I'm sure after this demo, Peter's gonna like the man. All right. So on here you can see it when it does the pierces, these little blue dots. It's doing so on the edge of our shape, and it's not doing lead-ins. So when it does the pierces, it's just going to go to the edge of our shape and start cutting, which results in our shape having like blowouts on all the edges. So that's one reason for not doing it on here. That's a thing that they could fix, but it's kind of complicated to do that in the controller. So yeah, that would be, I guess, the reason why you would want to use SheetCam over here using the software. Other than that, this is what I was chopping off earlier. So these were little circles. So we're going to load up our file, which is here. And the only thing I cheated on, I flooded our table earlier. So there's a big stock tank down below the plasma cutter that's full of water. So this little table is water for a lot of the energy. And then we're going to set our 0 on here. So right now my tool is this little yellow line getting drawn around. And as I'm moving it here, you can see it moving over there. So what I want to do is make sure I have enough stock, because I don't want to run off my material. So that's like dragging a boundary around the front. So we got plenty of space for goal. So that's stuff all good. And then on here, our only other critical thing is to make sure that our material is set correctly. So I had to pick on here 16 stainless steel, high quality cutting, and then it comes in automatically. The feed, the voltage, and the amp. So on that note, never a good idea to have like sandals in a hot shop, what we call it. So my assistant here has got his sandals on. It's gonna be entertaining. So he starts jumping around to the camera. That's why. This is our code I was trying to pull up earlier. So this is just got our moves and whatnot in it.
I've got a question from the audience. You loaded your NC file and you talked about this, but you did all this in SheetCam.
I didn't, in fact. So this is partially a lie. So the only thing that mattered in SheetCam is that I had the curve offset correct.
Okay.
This stuff all comes from here. In fact, if I had different material, let's say I came back here and I went, oh crap, I'm out of 16 gauge. I can actually switch to 12 gauge and it would automatically change my whole code. Except it wouldn't fix my offset, so my sign would be burned. It would lose more material than it's supposed to if the material's thicker. So we would have a bigger curve that would be lost. So aside from that, this is actually set up. There's two ways to kind of set this up, and in this case, it's set up so that this onboard controller is doing some of the work, and my software is doing some of the other work. And I'm working on writing a post processor that does everything on the post processor. Some other advantage we don't have to get into. So. Anybody in the actual audience have any other questions about anything? Otherwise, we're going to hit go. So speak now or forever hold your ears. This will definitely be probably loud. So fair warning, if you got your speakers turned on or your earphones or something on, it's probably going to be kind of noisy. So everybody ready? literally just start out here. There's like no motor in it. Yeah. All right. So when my computer crashed earlier, I grabbed the wrong post processor file, even though I'd already prepared this earlier. So let me run back. Davey's gonna entertain you guys, and I'm gonna go regenerate my code. So my code in here, this is my experimental post processor that doesn't entirely work yet. So I'm gonna go figure that out. So maybe it'll run interference for me.
I'm gonna try to figure out how to get this phone to rotate and look at all of Chris's settings while he's gone.
You could try turning off the video and then rotating and then turning the video back on.
Well, he had auto rotate turned off. Did it flip for you guys yet, or is it still sideways?
Still sideways.
All right.
Forget that. Dig through his texts. Find something embarrassing. Text his parents.
I think he's a smart cookie. He's got it set up. That's still sideways for you, isn't it?
Yeah.
Well, that surpasses my knowledge of whatever this program is.
That's fine. Just so you know, when it gets too far away from Chris, we can barely hear his voice.
Yeah, okay. And I'm trying to fuzz the line of like showing you what he's doing and listening to him. That's good to know though. Once this thing fires up, I'll be standing back so you can see kind of the whole thing running. So while Chris is gone, if anybody hasn't seen it, this is the plasma table. And so then, you know, it's a kind of a massive structure. You've got 4 feet by 4 feet of bed. You've got the water basin here. You know, other than that, the rest of it's pretty boring. You know, the controls over here, the plasma torch down there. I got the boss back.
I can't tell the water level. Is the piece underwater or just above the water?
Does this help you out?
Yeah. Okay, cool.
And then he's just got these big heavy weights holding this piece in place.
The water's highly toxic. You should never touch it. Oh shit. No, it's just treated to be a very high. It's a base, high pH, basic to keep it from rusting. So actually, you inhibit rust with the high pH. Kind of fun. It's a nitric. How's it? Sodium nitrate. Sodium nitrate. It's a meat additive. What's in there? So, all right. So we're good to go. I'm gonna hit go. Ready? Great. Yeah. So close.
So while this thing's running, it has a torch height controller that's constantly controlling the height of the cut. And in this case, our material warped up and started touching, which is why these letters are distorted. So it was moving our stock. So in this case, our torch was trying to maintain height as close as it can. So it stays about 20 thousandths above the material. And our material bent too far. And so it ended up making contact. And so it stops itself when it makes contact. So our cut here is quite artistic, needless to say. Yeah. So I will finish this either by writing, I'll go back to the software and I'll just draw a line from here and just finish the cut that way, or we'll chop it off conventionally. It's still plenty good for a yard sign, but to give you an example, I've been cutting like for a fair amount today. And so these are all successful cuts. So the odds of failing a cut in front of you all for the meeting are quite high, as that's how live demos work. But the thing was running for a couple hours earlier just fine. So it's par for the course. If I had a bigger piece of stock, that would be a lot better. I'm using up scrap from the cuts that I was doing earlier. So anybody got questions about this? I'll make my way back to my laptop again.
Did you check with Elon Musk on how to give presentations?
Yeah, we should. I hear he's quite good at screwing them up in real time, but this isn't like smashing a window on a truck I'm trying to sell, so not too bad.
It was interesting how the audio of that came through with all the compression and everything. It sounds like a little kid trying to whisper a secret in your ear, but mostly just spitting.
All right, I'm gonna switch back over to my computer here. Hang on one second.
So did it like jump from side to side because it was like letting an area cool or something, or it didn't like go linear across the piece?
Oh, my laptop is angry. Yeah, so it hops around to be able to distribute heat stress to try to minimize distortion so that we don't have problems about the material melting or material moving.
So can you like, and then basically just set pauses in there short of manually manipulating the G code?
Yeah, the post processor can do anything. So we could make it so it pauses based on how long it's been cutting or how big the part is or small the part is or anything like that. So you could get super sophisticated and making it fancy, but any other questions from anybody?
How thick will it cut through stainless?
Ah, there we go. That's a perfect question. Let me check and see. I know we can do 3/4 inch, actually 1 inch mild steel.
And how clean are the edges on like 1/8 inch or narrower?
They are quite clean. So they've got a tiny burr, but that's about it. 3/4 inch stainless and 3/4 inch aluminum as well. Those are both harder to cut versus mild steel kind of flows better. All right, Mr. Bob, you want to take it away?
Sure. Danielle has been wanting a picnic table, and I was originally planning to wait until it wouldn't cost an arm and a leg. However, I went into my garage and looked through all of our spare wood, and basically it turned out I had exactly enough to make a picnic table. So let me share. Okay, so I found a website called Bob's Plans, which, you know, I'm Bob, so perfect. And it had some instructions. These instructions were really well put together. It had the not only was the website good, but there was a PDF, which had like all of a whole description, a parts list with exactly everything that I needed. And then there was this really cool part where it had like, these are the 2x4s and the 2x6s and how to cut each one to maximize what you had for materials. So I started with this. However, I did not have all of these materials in the correct amounts. So for example, the 2x6s that I had were, I didn't have treated 2x6s, I had treated 2x4s. And so I had to modify the plan slightly for that. And then I didn't have enough 2x6s to do the bench parts, but I did have enough 2x4 material. So I just did 3 2x4s rather than 2 2x6s. And then this part here for attaching the legs, I didn't have enough 2x6 material, but I had, or no, this calls for 2x4s, but I didn't have enough 2x4 material, but I did have barely enough 2x6. So all of this somehow ended up being nearly exactly the length of materials that I had. And this is what it ended up looking like. So overall, I'm really happy with it. So the instructions called for having the legs kind of in a bit. And when I made it, I put the legs as far out as possible. And partly that was because I didn't read the instructions well enough, but in retrospect, I feel like it's better this way because I don't know how many picnic tables I've sat on where